Okay, so I'm gonna let you guys off the hook here. Sounds like you guys are trying to find 12% and subtract it. The problem is the 12% come out of the 286. Well, the 12% is already out, right? If I list the 12%, the 12 represents the discount, which is what we're trying to find, so that's good. But what's the 100 represent? The full price. In other words, before the discount. We don't have either of those numbers. We're looking for the discount, but we don't have the full price. What we have is after the discount. So what we need to do is figure out something that represents the 286. What percent represents the 286? 88% is the price after the discount. So we could do 88% is 88 out of 100. Put the 286 in here because that represents the discounted price or price after discount, the same as the 88% does. Cross multiply and divide, we get what? 325, I believe. Somebody double check me. 325. So $325 is the full price. Are we done? No, what do we still have to do? Yeah, $325 is the full price. We subtract the price we paid of $286. We get $39 is what we saved as our discount. Now there is a way we could short this even further. We got our price before discount. We're going to subtract from it the discount to get our price after discount. Remember, each number is represented by a percent and then some other number. In this case, it's dollars. We know the 286 is the price after the discount. On the other side, we know the discount's 12%. But we also know that the price before discount has to be represented by 100%. So then this must be 88% because we are subtracting. We want the discount right here. We don't care. We don't really care what the full price was before discount. We just want what the discount was. Well, I don't have to go to the 100%. I can compare the 12 to the 88. I can cross multiply and divide right here. 12 times 286 divided by 88. Will give us that same $39. This table right here, I think I did it a couple of times yesterday to show you guys. When I do percent increases and decreases and stuff like that, markups, markdowns, I use a table like that all the time because that table helps me keep things straight. And you can see here, I did my cross multiplying and dividing right in the table. I just crossed off the line that I didn't need to use. I need one line. I have to have at least one line where I have both numbers, which in this case was the price after discount. And I have to have the line that I'm looking for, which was the amount of the discount. That's all I need. And I can do, like I said, the cross multiplication and division right inside the table, which is a really handy tool. If you get good at it, it's a very handy tool to use. Any questions? All right, so for our new stuff today, we're going to talk about a topic that's maybe not real applicable to auto and welding, but it's applicable to life. And we're going to talk about interest. Most of you at some point are either going to earn interest on an account or pay interest on a loan, or both, well, most likely. We're going to start out with the simplest form of interest called simple interest. And simple interest, like I said, is the simplest way of calculating interest. And what it does is the interest is only calculated in one of two cases. Interest is calculated either when there's an action on the account, when money is either put in or taken out, or at the end of the term. Now, a lot of people don't think simple interest is used very often, but it actually is. Like most of your car loans are simple interest. Well, you're sitting there thinking, well, don't I pay interest every month on the car loan? Yeah, but you also have to do what every month? Make a payment. So every time you make a payment, they figure out the interest. That's an action on the account. If you make the payment early one month, you look at your stub and generally there was less interest on it. Then the next month you make it at the normal time and there'll be more interest on it because there was a lot more days in between, so there's more interest. Most car loans are set up that way. Many of your home mortgages are set up that way as well. That's why a lot of banks don't allow you to get more than 1 or 2 payments ahead of schedule on your loans, because you can actually pay 4 or 5 payments ahead of schedule, and now you haven't paid interest on a lot of those payments, so you've paid down your principal faster, and in the long run, it saves you money. If we get time, I'll show you an example of that before we're done today. So for simple interest, the formula is the amount of interest, I is a dollar amount of interest, is equal to principal times rate times time. So P is the principal. Principal is the starting amount. R is a rate. A rate is a percent in decimal form. Now we talked about that last class and before of sometimes it's better to use the rate method of percents. Here they technically are using a form of the rate method of percents. And T is time in years. So let's say you invest $4,000 at 8% for 3 years. Your amount of interest, I, is going to be, what's your principal going to be? $4,000. Your rate, 8%, we have to put it as a decimal, so it'll be 0.08. And your time, 3 years. So that's going to be about $960 is your interest. So what that means is at the end of the 3 years, FV stands for your future value or your ending value. You have your original $4,000 plus $960 in interest. So you have $4,960. What do you think? Not so tough? Okay, I'm hearing crickets. It's okay? Most of the time, they won't use simple interest for something that's going to be sitting there for 3 years. Like we said earlier, they only use simple interest for something they expect to have action on a regular basis, like a car loan or a mortgage. If it's something like an investment where there aren't going to be regular payments or regular actions, they generally won't use simple interest for 3 years. They might use simple interest, though, for a few months. So let's say that you're going to invest $2,000 at 5% for 3 months. And I want to figure out how much that's going to be worth at the end of the 3 months. Well, my amount of interest is going to be, what's my principal? $2,000. What's my rate? 0.05 for the 5%. Now I said time is always in years. So 3 months, we're going to write it as 3/12, 3 out of 12. or 1/4, yes. I just leave it as 3/12 because then you can see that it's 3 months out of 12 months for a year. But yes, you could reduce it to 1/4 for your calculation. What does that give us? Like $25, I believe, is our interest. Somebody wants to double check me? So then our value at the end of that 3 months is our original $2,000 plus the $25. So $2,025. So now, right now, 5% is a dream. Anybody have a savings account? Do you know what you're getting for interest? Most of your savings accounts are getting like 0.2% interest. Yeah, they used to be getting like 2 or 3%. Now they're less than 1/4%, less than 0.5%. Some of them are getting 1/4 or more. But just go, you can borrow money. My home mortgage, I just refinanced my house at 2.8% interest. So if you're usually what you earn is 2 or 3% below what you're going to pay in a loan. So interest rates for borrowing are so low, they're not paying anything for savings accounts. I predict that that's going to go up very quickly in the next 2 years. That your mortgage, I'd say your mortgage rate's probably going to be up around 4.5% or 5%, which is probably where it should be. And your auto loan rate's going to be around 7 or 8%, which again is where it should be. Then you're going to see your savings accounts get up to that 2 or 3% again. Now this used to happen to me quite a bit. Oops, did you need that yet? I run a construction business on the side. And you'd hit your 2 weeks where it's time to pay your guys, but you haven't finished a job, so you haven't had a check coming in yet. So I go to the bank quite often and say, hey, I need $4,000. Yeah, since I used $4,000, say I'm going to borrow $5,000 here. And I'm going to need it for 2 months. Usually they'd call it a 60-day loan, but we're just going to say 2 months to make the math easy for us. And they say, okay, we're going to charge you 9%. How much am I going to have to pay back at the end of that 2 months? Well, the amount of my interest. Tell me what to write in here. You got it. Perfect. So my principal is $5,000. That's what I started out with. My rate of 9% becomes 0.09 as a rate. And 2 months is 2 over 12. This one I'm going to have to punch in because it's going to get ugly. $75 is my interest. So that means at the end of my 2 months, my future value, I have to pay back my $5,000 plus the $75. So it's $5,075. So it cost me $75 to get that money for 2 months. So that's simple interest. It's really quite simple. Now, what if we go back to that original problem? You're going to invest $4,000 at 8%. Now notice I'm leaving a gap here for 3 years. They generally will not do 8% simple interest. They'd probably do 8% compounded quarterly. What does compounded mean? Well, compounded means they add in the interest regularly. The quarterly means once a quarter or 4 times a year. Every 4th of a year, they figure out the interest and they add it in. So what that means is they add in the interest, so then in the next quarter you earn interest on top of the interest. Your principal has gone up by the amount of the interest, so that's now increasing the amount of interest you get. That's why it's called compounded, is it's building on top of itself. So to do that, they figure out the interest every quarter. So in quarter number 1, the amount of interest we earn is $4,000 times 8%, 0.08 times 1/4. It's a quarter of a year. It's going to be what, 80 bucks? Which makes our ending balance 4,000 plus 80, or $4,080. Make sense so far? Quarter 2, the amount of interest we get. Well, the principal is no longer 4,000. 4,080. So this is going to be $81.60 we get for interest. So now our balance, $4,161.60 is our balance at the end of the second quarter. So you can see we're already getting more interest in that second quarter because there was interest already added in. And this would keep going. It would increase each time. Now, how many times would I have to do this to get through 3 years? Yeah, 12. Quarterly means 4 times a year for 3 years. I don't feel like doing this out 12 times. I just don't want to. So let's take a look at what happened here. We were just talking about percent increase, right? We had our $4,000 principal. We added the interest to it, which was $80. We got $4,080. Well, on the other side, the principal was 100%. The interest was what percent? Well, we had our 8%, but times 1/4, right? That'd be 2%. So at the end of that period, our ending balance was 102% of what we started with. Let's check that out. If I take 4,000 times 1.02, that's 102% as a decimal, as a rate. That will give me 4080, which is my ending balance here. If I take the 4,080 times 1.02 again, I will get the 4161.6, which is what my ending balance was here. So each period, I just have to multiply by 1.02. How many times do I have to do that? Still 12 times, right? But in math, do we have a process that allows us to multiply by the same number over and over again? The 12th power, very good. Oops, that should be 4,000, not 4,100. So 4,000 times 1.02 to the 12th power gives us 5072.97. That's your total. It's your balance at the end of the... Now remember when we did simple interest, it was $4,960. So there's about $113 more because of the compound interest. So you've got this formula where you take your beginning balance, your principal, and you're going to multiply by 1 plus your rate, where your rate's divided by your number of periods in a year, to the power of your number of periods. That's what we did here. We took our beginning balance, was the 4,000, times 1 plus, our rate was 8%, 0.08, but it was divided by 4 because there's 4 periods in a year. That's why it was 1.02. And then to the power of 12, because 4 periods a year for 3 years was 12 periods. Rate divided by n, which is n is the number of periods in a year. So quarterly would be 4. If it was monthly, of course, it would be 12. So let's say you invest $8,000 at 6% compounded monthly for 2 years. Now, we did the 8% divided by 4 and got 2, but we don't have to do that out. We can actually do this like this. We've got our, this is going to be our future amount. We don't find the interest by itself when we do compound interest. We've got our principal of $8,000, and that's going to be times 1 plus 0.06 divided by what? 12. 12 periods in 1 year. To the power of 24, because we're going to go for a total of 24 periods. But our interest is always divided by just how many times in 1 year. So 8,000 times, I'm going to put this in parentheses, 1 plus 0.06 divided by 12, and I'll close my parentheses, the power of 24, 9,017.28. Like that. Any questions? The one, that's the 100%.
So you can just skip the first step and reinvest interest and just go straight to the future value.
Yeah. When you do the compound interest, you don't find the interest rate. The only way to find the interest when you do compound interest is to find that future value and then subtract out the principal. Yeah, that's a 1 here. Now I want to do, there's one example I always like to do for my classes. How many of you are under 23 years old? Under 21? Okay, perfect. So I know you're stuck with me, but I grit my teeth and bear it when I do this example because it makes me want to cry. Let's say you get out of school and you're 22 years old. Now, while you're in school, you're living kind of cheaply. You're maybe sharing an apartment with roommates, driving that old car for a few more years, eating cheaply. You're not going out. You're not doing wasting a lot of money on recreation. You're living cheaply to get through school. So then you get done with school and you get that first good job. Starting to make decent money. A lot of people want to get a better car, move into a nicer apartment, whatever. But what would happen if you stayed living the way you were for a couple of years? You could save a lot of money. That first year, how much do you think you could save? 30 grand? Well, maybe not quite that bad. But how about 10? Or how about we say 5? The reason I say 5 is, and actually I think it went up to 5,500 this year. 5,000 is what the federal government says you can put away each year for retirement accounts. In fact, let's just take a peek here quick and see what. Into each year into what's called an IRA. You can put it into tax shelters. You can put more in. Or you can get up to a certain percentage of your income. I think it's like 20% of your income can go into tax shelters. Here, let's do the max IRA contribution for 2017. I believe it's gone up to 5,500. But yeah, 2017 it went up to 5,500. Individual retirement account. If you're over 50, it goes up to 6,500. But for TSAs, for tax shelter annuities, now for a tax shelter, it has to come out of your paycheck. That's the difference. An IRA, you just have this money sitting there, so you go put it in an IRA. A tax shelter, it has to come out of your paycheck every month or every pay period or whatever and goes into it. A lot of your works will have TSA matching, they call it. So they'll match up to 2% of your pay. So if you're getting paid, let's say you're getting paid $600 a week, 2% of that is only $12. But they'll put, if you put at least $12 into a tax shelter, they'll put that $12 into it, which it's $12 worth of free money. Most tax shelters have a minimum $25 per pay period or whatever, $25 or $50 a month contribution. So you might have to put in a little bit more than what they'll match to make it work, but you're still getting free money from your employer. So anyway, you can save $5,000. Retirement right now, the federal government has said that people my age will not be able to retire until after 67 to get full Social Security. You get partial Social Security at 62. For you guys, it's probably going to be 68 or 69. In fact, they've even said that if you're born after a certain year, it gets pushed back 1 month per year that you're born after that year. So for me, it's going to be like age 67 in like 10 months or something like that. But let's just keep it simple. Let's say 67 years old to retire. So that is 45 years. Yes, I know that's depressing to think that you're going to work for 45 more years before you retire, but here's the joy of that. What type of interest do you think you can get? Now, I'm not talking about going to a bank. I'm talking about going to a professional investment planner, a State Farm, an Edward Jones, Fidelity, somebody who does investment for a living. What type of return do you think you can get on that money? What type of percent? Okay, 5 is actually very conservative. The average 40-year return, annual 40-year return over even including periods that had like the Great Depression in the 1920s and 30s, and even periods that included the big crash in 2008, 2009, where some people lost. I mean, I lost like 27, 28% of my investments in like a matter of a year. But even with that big loss, I have still averaged between 12 and 13% a year gain. Because I had years where I gained 20, 25%. So let's be conservative and say 10% is your annual gain, 10% per year. Now we're going to keep this simple, and we're only going to compound interest once a year. So this is going to be $5,000 times, remember it's 1 plus 0.01. It's divided by 1 because we're only going to compound interest once a year. Does that make sense? There's only 1 period per year. So it's going to be the power of 45. Because 1 period a year for 45 years is 45 periods. Does that make any sense?
So I guess if it's just once a year, you don't have to write it.
You don't have to write it divided by 1. No. Yeah. I just wrote it up there to be consistent. Yep. Anybody want to guess before I hit equals here? 7,500? 75,000? 364,552. That's over 1/3 of $1 million. Did that 3 years in a row, you'd have $1 million sitting there.
You put the profit back into it.
Well, that's taking your interest and keeping your, but you haven't invested any extra into it. That's just $5,000 once at age 22, and you let it sit there for 45 years. Yeah. Now, let's say you wait till you are 32 years old. That would be about you. We're going to assume you can still get that 10%. Now you only have 35 years. Anybody want to guess? 220? About 140, 512. Yeah. Way less than half. Not almost down to 1/3 of the amount. Yeah, about 40% is what you're going to get. What if you screw up and get to my age? I'm 43, but we'll call it 42. So it's 5,000. Now it's only 25 years. Anybody want to guess? 54,174. Roth IRA will give you the same compounding. The difference between a Roth IRA and a regular IRA is if you put money in a regular IRA, you get a tax deduction right now for it. But when you draw it out, then you have to pay taxes on the money. A Roth IRA, you do not get a tax deduction right now, but when you draw it out, it's tax-free. So a Roth IRA is very versatile. The other thing about a Roth IRA is, let's say you've got $5,000, that's your emergency fund. You can put it into a Roth IRA, and let's say 5 years from now or 2 years from now, an emergency comes up and you need some money, you can take out your principal, and there's no penalties on it. Yes. You can take out the principal. You can't take out the interest. There's penalties if you take out the interest, but you can take out the principal without penalty. So that original $5,000, you can take that out at any time. Well, you can only put up to your $5,000 per year, so you can't ever pay it back.
Oh, okay. But you can still add more.
You can still add your $5,000 every year to it. Yes. Okay, so now, yeah, if you waited till you're 43 or 42, you get about 1/7 of what you would have if you did it at 22. To me, that's just amazing. Now I'm going to pull up a spreadsheet here. You guys aren't required to do anything with Excel, but I want to show you guys just how powerful this is. Since we got 2 younger guys in the room, I want to show you the power of being young. So we're going to start out at 21. Yeah, we're going to go to 67 here. Now we're going to do your $5,000 investment every year. 67. Come on. Anybody want to guess what if you put away that $5,000 a year every year? Oops, going wrong there. Oh, I pulled the wrong thing. Let me try this again. Yeah, that's probably it. The 1.1, you are correct. That's the difference. So you ready? That's saying the number's too big to fit in the space. Anybody want to guess? 4.4 million almost.
You invested $5,000
every year.
With interest.
Now that's.
And that was 20.
That was at 10%.
That was 10% interest.
Which is not hard to do, really. It is not hard to do 10%. You go to a professional investment planner, they'll get you 10%. Now I've got to show you these examples here. Yep. Okay, I've set this up so I can do 2 examples side by side. In this example, this person here starts at 21, puts away $5,000 a year until they get to be 30. At 30, they say, you know what? I've saved money. I want to start playing with my money now. So they did it 5,000 a year. That's 10 years there. Actually, 9 years is all they put it away for. At 30, they say, you know what? I'm not investing anymore. I'm not putting any more away for retirement. I am going to play with my money for the rest of my life. I'm just going to leave that money I've already put away, but I'm going to play with every penny I make for the rest of my life. How much do you think they're still going to have?
3/4.
2.5 million.
What?
This person over here at 21 says, you know what? I'm young. I want to party. I want that new truck. I've gone to school. I've worked hard. I'm going to play for the next 9 years. Then at 30, they say, okay, I should start saving for retirement. So at 30, they start putting away $5,000 a year, and they do it every year till they're 67. So this person put away $5,000 a year for 9 years. This person's put away $5,000 a year for 38 years, from 30 to 67. Anybody want to guess how much they have? Way less.
1.8.
Way less
Whoa.
interest. Now you think about it, this person put $5,000 away for 9 years. They put away $45,000. This one put $5,000 away for 38 years. They put away $190,000 and didn't catch up because the other person had more years worth of interest. In fact, let's push this back a year. Put a 0 there and a 5,000 here. This person's still going to have way more, a couple $100,000 more.
$250,000 more.
Or something like that would be, like, by the time you get to that age where you start, you want to start just living off that money.
Yep.
Living off that area would be better because you get taxed a lot depending on how much you put that in.
Well, yeah, and starting at age 70, I believe you're required to take a certain percentage out every year. So you have to take money out of your retirement accounts at a certain age. You can start drawing out at 59 and a half. So basically you figure 60 years of age, you can start drawing out. So even at 60, you'd be still sitting at $1 million. But yeah, that last 10 years, it almost doubled, or that last 7 years, it almost doubles for you.
So riddle me this. On the first example, since you have
Yep.
zeros to the end, what would happen if the last 10 years you bumped it to 10,000?
Oh, like back here.
Or the last 5 years.
So he had 5,000 here.
Yeah, 5,000 all the way down, but then he decided last 5 years he's going to bump it to 10. What would that mean?
It doesn't help as much as you would think. It gives him an extra $80,000 or $90,000 is about it. Now that's 43.59. If I come back here, did the 10,000 in the first year, takes you up $1 million, or $500,000, $500,000 almost. It's that first, your 20s. If you're investing for your retirement, your 20s are worth more than the rest of your life. So in that 8 or 9 years that you have for making money in your 20s, because obviously you're not going to start till 21, 22, but that 8 or 9 years you have in your 20s is worth more than that next 35 years of your life is as far as savings for retirement. It's very powerful. Yeah, it's kind of scary.
So wait, keep that up and scroll down. On the left, so then you could retire by 58.
Yeah,
I mean,
as a millionaire, yep.
yeah.
Here's an example I used to do. I used to have people that I talked to, friends that I talked to, that saved up money for their kids' college funds. And their kids would be, 15, 16 years old. They'd be, sophomores, juniors in high school. And they'd have like 8 or 10,000 saved up for their kids to go to college. And they're like, well, what can I do to save money to pay for my kids' college? And I'd always tell them, don't let your kids use that money for college. Unless you've already got it in an educational fund. If you just got the money saved up in a bank or whatever, at the age of 16, you can start putting money away in an IRA. The only catch is you're allowed that 5,500 limit, but you're not allowed to put in more than what you earn. So let's say at 16 you get a part-time job and you made $2,100 that year. Your parents can take out of that college fund or whatever, wherever that money is sitting, they can take $2,100 and put it in an IRA in your name. Because you earned $2,100 that year. You still get, your kid still gets your money and goes and spends it and does whatever they want, buys gas or whatever. But then you take that $2,100 and put it in an IRA for them. Let's say the next year at 17, your kid has a part-time job and they make $2,800. So they take $2,800 of that dollars and put it in there. At 18, working part-time a little bit more, maybe they make $3,400. Now here, if you look at what they've put away here, that's still not the full 10,000, right? But they've put it in an IRA rather than in a college fund for college. They just gave their kid $1 million retirement fund. Now let's see what's left here. This is what? 4,900. 53, 8,300, so there's 1,700 left. So let's say the fourth year they put the rest of that 1,700 away for them in their retirement. They're definitely now over $1 million in their retirement. That $10,000, if you let your kids spend it on school, is going to cover a year, maybe a year and a half. Oh, tech college will make cover a year and a half to 2 years. If they're going to a 4-year college, it's not going to pay for their college anyway. And not only that, but there's financial aid and stuff like that that should help out. Even if you have to take out a student loan, all you have to do once you're out of college is pay back your student loan. Your retirement is all set. You don't have to worry about putting money away for retirement. So it's easier to pay back a loan than it is to save money paying ahead for what you're going to want in the future. So that student loan, you have to pay that every month. So you're going to do it. To me, this makes way more sense. You've provided for your kids' retirement. They pay their own way through school. First of all, if they're taking out loans, it's more valuable to them. They're less likely to blow it off. But also, like I said, all they have to do is pay back that loan. They don't have to worry about retirement. So anyway, I'm going to shut this down. In your book, page 97, problems 1 through 13, the odds. There are a couple of problems towards the end of there that talk about annuities. We did not get to annuities and amortization. Amortization of a loan, we'll talk about that a little bit tomorrow if we have some time. That won't be on a test or a quiz, but I might make it an extra credit question, so if we get some time, we will still talk about it. So in your book, page 97. And I've went long-winded.